Imagine estimating a $10 million project in just minutes and being right within 3% of the final cost. Sounds impossible? That's the magic of parametric estimating. You're about to learn a technique that Fortune 500 companies, aerospace giants, and cutting-edge tech firms rely on not to guess, but to predict with precision. From data to dollars, mastering parametric estimating for project success. Parametric estimating is like using a formula to forecast your project's cost. Instead of estimating task by task, you use key variables and historical data. It's not magic, it's math. And it works. Example, if it costs $300 per square foot to build a hospital and your plan is 100,000 square feet, you can estimate total cost instantly. Simple inputs, reliable outputs, but only if you know how to set it up right. Step 1. Define the parameters. Find the measurable variables that drive cost: square footage, lines of code, number of units. Step 2. Collect historical data. Use past projects to determine unit cost. The more reliable the dataset, the more accurate your estimate. Step 3. Implement the mathematical formula. Insert your project variables and boom, you've got a reliable estimate. Step 4. Modify the estimate for risks and external influences. Revise the estimate considering factors. Step 5. Validate with experts. Your math is only as good as your logic. Review with your team. We teach you all of this with guided and industry-specific examples in our full online course. Pros: super fast once set up, highly scalable for large projects, repeatable and defensible, works great with historical data. Cons: needs reliable historical data, can oversimplify if variables are wrong, not ideal for brand new, unique projects. The bottom line? Parametric estimating is incredibly efficient, but only if your foundation is solid. Case Study 1. Government Highway Project. Used lane-mile costs from past projects to estimate a new 300-mile highway. Original guess: $2.1 billion. Parametric estimate: $2.18 billion. Final cost: $2.17 billion. Case Study 2. Software development firm. Used cost per function point from 10 prior apps. Saved 6 weeks in planning and hit the budget target within 5%. Case Study 3. Hospital construction. Leveraged cost per bed model from 12 hospitals. Estimate built in 1 day versus 3 weeks using traditional methods. When done right, parametric estimating doesn't just save time, it saves entire projects. Here's how parametric estimating fits into your project lifecycle. Initiation. Use it to quickly define feasibility. Planning. Use for baseline cost and schedule. Execution. Compare actuals to predicted values. Control. Reforecast with updated variables. It's especially useful for early-stage decision-making and portfolio analysis. This technique is trusted by NASA and Boeing Aerospace, McKinsey and Deloitte Consulting, IBM and Oracle Tech, U.S. government agencies, infrastructure, engineering and construction firms. Anywhere data is available, parametric estimating gives you a competitive edge. Accuracy factors. What makes it reliable? Quality of historical data. Consistency of unit definitions. Valid range for each parameter. Continuous model updates. Human judgment for fine-tuning. Our course goes deep on this, showing you how to assess and improve the reliability of your models. Let's recap why you need this skill in your toolkit. Faster estimating equals more time for design. More data equals more defensible budgets. Scalable from $10,000 to $10 billion projects. You become a forecasting asset, not just a planner. Stakeholders trust what they understand. With the right data and training, you'll estimate smarter, not harder. Want to master parametric estimating in real-world scenarios? Enroll in our online course where you'll get: what is parametric estimating? How to make parametric estimating models. Best practice, pros and cons of parametric estimating. Case studies, parametric estimating in action. How to use parametric estimating in practice in finance and project management application. Who uses parametric estimating, why it works, and what to watch for. Stop guessing. Start forecasting with confidence.